A lot of people are having trouble converting from the lanthanum to the lanthanum 3 chloride. So what I've done is I've established the reactions that we're going to use. The first reaction is the original one from the lab that we did. The zinc metal plus HCl to yield zinc chloride plus hydrogen gas. All right. We trapped about 0.03 moles of gas. So we're going to use that number throughout to determine our 3 metals that we're going to look at with their reaction with hydrochloric acid. So we're going to start with lanthanum and HCl. They give us that it makes lanthanum 3 chloride, right? Remember, lanthanum is a transition metal and actually has lanthanides named after it. So it gets a Roman numeral in the name. We're also going to make hydrogen gas. So we have to balance that out. Best way to do it is 2 lanthanums and 2 lanthanum chlorides. That gives us 6 HCl and 3 hydrogen gas. So in the original reaction, the ratio was 1 zinc to 1 hydrogen, 1 mole of zinc to 1 mole of hydrogen. We had 0.03 something approximately moles. So we started with about 0.03 moles of zinc, and we ended with about 0.03 moles of hydrogen. We're going to use this hydrogen again in this reaction. So in this reaction, we're going to assume we made 0.03 moles of hydrogen. Now we have to convert that moles to moles of lanthanum to find out how much lanthanum we needed to make the amount of 0.03 moles of H2 gas. So we have that amount. Let's say it's 0.030852 moles of H2. We want to convert that to moles of lanthanum. So we're going to use the coefficients in the balanced equation, 2 lanthanums and 3 hydrogens. That's why they're in red, because those are the 2 we're looking at. So the 2 in front of the lanthanum goes on top because we're converting to moles of lanthanum from moles of hydrogen gas. The 3 goes on the bottom because we're converting from hydrogen gas, so that we want those to cancel out. We're left with moles of lanthanum. So 0.020568 moles of lanthanum is how much lanthanum moles we need to make this many moles of hydrogen gas. It turns out that it's a 2 to 3 ratio. So are we expecting what we got? And the answer is yes, we are. We're expecting it to be 2/3 as big as the original number, and it is. Okay, so now once we have that, the problem is asking us this: what is the ratio between grams of lanthanum and moles of H2? So we have to convert the moles of lanthanum to grams of lanthanum. So we do that by multiplying the number of moles of lanthanum times 138.905 grams of lanthanum over 1 mole of lanthanum gives us 2.85700 grams of lanthanum. So that's the right number. Now we're going to go back and grab our moles of H2 and put that on the bottom. So 2.85700 grams of lanthanum divided by 0.030852 moles of H2, and we get about 92.603 grams of lanthanum per mole of H2. And that's how you do that. You do the same thing for the next reaction, which I believe there's barium solid plus HCl yields barium, and being a second column metal, it's a +2. So H2, this one is going to be, let's see, 2 HCl. There we go, it's balanced. So barium is going to be 1 to 1, just like the H2. Again, we're using the 0.03 moles approximate. So if we were doing that for this number, this is what we would use to do the conversion between barium and hydrogen gas. We're also going to do the same thing for lead. So there you go. And that's how we're going to identify the unknowns in this experiment. Thanks for your attention.